Alright, welcome to the Chemistry 101. My name is John Wang, and I will be the instructor for the lecture and also for the lab. So today is the first day of the class. I will first briefly go over the syllabus, and then I will call each one's name, and you introduce yourself to the class. Right. I hope you are already familiar with the iCampus of JJC's website. Right. So once you get onto JJC's website, you can go to the iCampus. Once you get on the iCampus, you should be able to access all the class materials, the syllabus, the lecture notes, and also the lab menu. Right. So first, you choose the class. Our class is this one, Chemistry 101, Section 310. Right. So once you get on the class website, and you will see on the left side there are a few of those folders. Right. You want to get the syllabus. Syllabus is right here, and is a link. You click on the syllabus, and you will get the file. I'm not a Mac user, so I'm not very familiar with. But anyhow, we'll get it. So on the syllabus, we have the course outline and textbook and schedules and etc. So I'm not going to read the syllabus with you. I'm just going to talk about a few important points about the class. So this class, we meet 2 times a week, Tuesday and Thursday, from 6:30 to 9:30. So we were studying everything in this room. Someday we'll do the lab. When we do the lab, we'll go to the lab together. It's in the hall, so that's the lab room. Right. The textbook we need is the textbook. I think some of you get the textbook. Is by the author is Cho, and we use edition number 3. So I recommend you to get the textbook. You don't have to get the textbook with the master in chemistry.com. Just the textbook will be fine. The other materials you need is the lab goggle. In the lab, when we do the lab, we need the safety goggle. So this week is the first week, and we don't have really a lab. For this week, we just going to have the introduction, safety about the lab. So next week, I hope you will be ready, get the lab grammar. There are some other safety procedures, so we're going to talk about that later on as the class goes on. All right. So that's pretty much basically the two required material for this class. Recommended, optionally, you can buy a lab coat. You can buy a calculator, but I think most of you use iPhone. But I prefer you use you get a calculator, at least some calculator like this, so have those basic scientific functions. Because every time when we have a lecture, and I will do some calculation on the board or on the computer as example, and then I will require you immediately follow my example. You will do some practice. I call that CRE, which is standing for classroom exercise. Right. So that's about the material you need. And the objectives, the class outline is on the syllabus. Briefly talking, we are going to study the first 11 chapters of the textbook. So starting from chapter 1, you have the handout for the lecture notes. And then all the way to chapter 11. We're pretty much going to study every chapter in kind of details. So just prepare to put a good effort for the class. Right. So we studied those that textbook that 11 chapters, and then we also do the lab. The lab schedule, everyone has lab schedule. Usually we will do the lab maybe Thursday, the second day, unless we don't have a class. I think Thanksgiving week we don't have a class on Thursday. So then you can get the lab manual. You don't have to buy the lab manual from the bookstore. You can get the lab manual online at the same place I show you. Alright. So once you get on the website, and you will see the courses, and you go to the Chemistry 101 labs. See that? And then you go to the left side, and it has some handout. That's some handout. Right. So one is the lab schedule, the other one lab notes. Right. So you click on the modulars, and then you have those lab manuals. And this, I think this, those sequence, like which week and which week, is same as on the schedule. There are some extra materials on the website. You have the lab manual, which is the procedures. Sometimes you might use some other instruments, the lab quest, or some other technique, titrations used to be read. And you will see some of those files also on the website. All right. Now let's go back to the syllabus. All right. So we have the lecture. We studied 11 chapters on the textbook, and you should read the textbook and also read the lecture notes. for the first chapter, because the first day I don't think you have time to go on the website, so I make a copy for you. And now after this first week, I will depend on you to make your own copies before the class. A good way to study the class is read before the class. You need to read the book. You need to read the lecture notes before the class. Even though you probably will not completely understanding everything in the chapter on the book or in the lecture notes, but at least get a head start. So you get start earlier, you will be in good command. So you will know like what you need to concentrate, and what you don't understand, and what is difficult. So you can get the lecture notes on the same website. I'll show you when I get the syllabus. I have two formats for the lecture notes. I have the PDF and I have the PowerPoint. Depending on what medium you use. If you use iPad, you probably want to use PDF. If you're going to print out, you probably want to use the PowerPoint, because you can print out 6 slides on one page, or 2 slides on one page. PDF is very useful if you have the iPad. You can just open your iPad. You can just read that. So you started the class, and obviously you want to get some good grade. To get a good grade, and we have this rubric. It's kind of small, but I think you will be able to see it later on syllabus. So we have 2 middle term exams. So those exams I will give to you. The first exam will be for the first 4 chapters. Chapter 1, Chapter 2, Chapter 3, Chapter 4 is our first exam. The second exam is for the next 4 chapters, which means 5, 6, 7, 8. So these 2 exams is the so-called middle term exam. I write the exam. Each of these 2 middle term exams has 30 multiple choice questions. Then I will scale it to 200 points. So then we also have a quiz for each chapter. All the quiz for each chapter, 1 quiz for each 1 chapter. All the quiz on the canvas online. Is already available, for example, for the first chapter. You have like a certain due date. For the first chapter, the first quiz, due date is September 6th, Sunday, 11:59 p.m. You have like 5 times to try the quiz. I will take your highest score as your final score in your grade book. So that's the quiz. The purpose of this quiz is to make sure you practice. Practice on your own, and practice and study. Right. So then next we will have 11. I told you before, called the CRE. Right. So each chapter has a CRE. The class, C is the class, right? And R is room, and E is exercise. So that means we do those exercises in the classroom. Each chapter have a different number of those questions on the CRE. So I will give you the scantron, and all those CRE is multiple choice also. So you just mark the answers on the scantron. Take good care of the scantron, because we are going to use it for like for probably one scantron for 4 travelers. 2 travelers in the front and 2 travelers in the back. To write your name on the scantron, I give you the scantron, and then for CRE. So we will normalize those questions for the CRE. I think about something like 10% of the total grade. Not too much points, but that's like one part of your grade. Everyone get the scantron for CRE? Alright. So we do the CRE is I will do the examples. I will do the examples. Chemistry 101.
Yeah.
Okay. You hang out. We are talking about the syllabus, so you can read the syllabus later on by yourself. Alright. So we normalize to, we have 11 CRE, each traveler CRE. The first traveler maybe like 19 questions, second traveler 20 questions. Okay? So you will see those different points on your canvas, but finally you will see this, all those CRE together is 17 points, about 7% of your total grade. So we do those questions in the classroom. We can do it any way. We can do like group together and whatever. So I just make sure you can understand and you have a very good command of those programs on the CRE. The CRE also in the lecture notes. If you look open your lecture notes, you'll see the lecture notes I gave to you today, the copy, okay? And some of those slides with the CRE. So a good way to start this class, particularly the class here, this session, as I said before, is read the traveler before you come to the class. And also read the traveler lecture notes before you come to the class. And even better, start working on those CRE programs. Okay. Learning is a process. Most people to memorize something need more than one time of learning. You just read a book and do like one program. You probably later on you will forget it pretty soon. Okay? So to have a good grade in the class, I want you to study those questions many times. Each time you do the CRE, you just forget about what you did before. I mean, forget about what the answer you have before, and starting from scratch, and working through the problem again. And then you check your answer, and that's, I think, a little more efficient to study, to memorize, and to get good command of the material. Right. So then we have some other labs. We have 17 labs. So some week, some day, we'll do like 2 or 3 labs together. Some labs is very easy. So altogether we have 17 labs, and each lab you can do like 4 person as a group, as a team. To the most 4 person. If you like, you can have 2 person or 3 person. So I think we're starting with 4 person a group to the lab. The lab report is also a group lab report. You don't have to write your own lab report every time. Your group decides, today, this week's lab, you write, next week's lab, you write, or you write the first part, and he writes the second part for each lab report. So then you turn in together as a group, as a team. So the lab reports, most of the lab reports I will not require you to write a formal level report. So that means you don't have to write like what is the purpose, what is the procedure, and what is the conclusion, those formalities. So usually just write two parts. The question part, that's the first part, and then data and calculation, that's the second part. Questions, you will check the level menu online. There are two types of questions, maybe the pre-level questions, maybe the post-level questions. Not every level has all post. So just check carefully. If you have pre-lab, you do the pre-lab. If there is a post-lab, and sometimes maybe not have the word post-lab, just say question, and you do the question. So make sure you do the question, the pre-lab, and the post-lab. And that's the first part of the lab report. The second part of the lab report is what you get in the lab. We call that data, or maybe observations. And some of those labs maybe require some of those calculations, then do the calculation. Most times is relatively straightforward. You have the table from the lab menu. Right? So you just put those data in the table, and if we need calculations, so make sure you show me the calculation. Don't just show me the result. If you don't show me the calculation, and you probably lost some point. Right, so that's the lab. And then attendance, so I will frequently or randomly take the attendance. So then I will say, well, the first few days I don't know you, I will take attendance, but later on I know you. Even though I don't take attendance, I know you are here or not. So I will give you, if you have good attendance, like every second you are here, you get 30 points, which is 3%. So then the last one is the final. Our final is the so-called ACS style. ACS standing for American Chemical Society. It has 70 those multiple choice questions. And we will take that I think on December the 15th. So that final is December the 15th. And you have a 2-hour time limit to do the 70 question multiple choice problems, which is a nation standard, because there's a lot of different universities and colleges that use that. Right. I just have that summer class. I was very happy to see one of my students get a very good score on the test. Probably one of the highest score I ever had from my student, and she got 64 out of 70. Just like that, she's doing so good. Right, so you can get those ACS styles. The question is all the materials, all the material in the question is covered in our study. Okay. So you prepare the final, prepare that 2 middle terms by what I said before. Read the lecture notes before coming to the class. Read the chapter before you come to the class, and begin to do the CRE questions on the lecture notes. So that will give you some very decent grade. If you want to get very, very good, like that student gets 64 out of 70, you need to put more time, put more effort. That means you will also do those quiz in the textbook. I will have the quiz online. In the textbook, in each chapter, there is also a quiz. If you have the textbook, so at the end of each chapter, there is a self-test, a self-quiz. It's a very good question. It's a little different way than the way I ask in the question. Excuse me. What I mean, the wording is a little different. Maybe a similar topic as density or molarity concentrations or mass percent or draw the loose structure. But there's a lot of different ways to ask the question. So just get familiar with the different way of asking questions. Right. So this is about the grade of this class, and all those together you will have possibly, if every quiz you get perfect, every exam you get perfect, 1,000 points. Right. You have 1,000 points of whatever, and then if you get those percentage, for example 88 or higher, you will get A. 77 or higher, you get a B, and so on. Alright. For example, you can get 62% or higher, you will get a C. Alright. So that's about the grading. Alright. Now you can see that I put up a tentative schedule. So pretty much what day we started which chapter, we try to do according to the schedule. But sometimes we might do a little slower, sometimes might do a little faster. Right. So as I said before, final with the December the 15th, and we changed the time a little bit. Our usual class time is 6:30. Our remaining later on when we get closer to the final. So final is from 7 to 9, 2 hours. All right. Any questions about the syllabus? So let's go back to our class, and I will show you something I told you before. Right. For example, you can see the quiz here. Right. So you click on the quiz, and so each chapter has a quiz. And for the first chapter quiz, again, due date is September 6th. So all the due date for each chapter quiz is on the syllabus in the schedule. Or you can get on the iCanvas, you can check the schedule, you will see that. Right? So make sure you try the quiz before the due date. If you don't submit, if you don't turn in you click on submit or save of your score for the quiz, you probably will see your point you get, but it will not be in the grade book. So I think last few semesters, sometimes I have a few students, I look back at his grade, he did so pretty good on the final and pretty good in the few quiz he missed. Probably he thought he not missed, but so if you turn in late and you don't have credit, if you miss the credit, and that can make a difference between A and B, B and C. Alright, so then the lecture notes, see the lecture notes, I have the lecture notes in PDF, and I also have the lecture notes in PowerPoint. Right, so you probably want to print out, use PowerPoint, and you probably want to read it with PDF. All right. Any questions so far? Some questions? Okay, so then let's get familiar with each other. And I will alphabetically call each one's name, and then you tell me your little about yourself, like what is your chemistry background, and what is your major, and why you take the class. Right. First one is Crystal Alvarez.
Okay. I'm here for a pediatric nurse, and I'm taking the class because it's mandatory.
Okay. Jonathan Anderson.
Hello there. I'm taking the class because I need to.
Okay.
About it. Don't know anything about chemistry. Haven't been to school in a while.
Oh. You had a chemistry before, like in high school, no?
Yeah, something like that.
Okay. You know, like those Kira, a few of those name of the elements?
Yeah.
Okay. That's. Armando Ativa.
I'm a bio major, and I'm required to take this class, so I have to take it. I did chemistry in high school.
Good. Aziz Barakat.
My name is Aziza, and you can call me Z. It's easier for you.
Okay.
I'm majoring I'm not deciding my major, but maybe pharmacy or medical school.
Mhm.
I have no chemistry background. The last chemistry class I took was 1994, which is second year of high school.
Oh. 1994.
Yeah, I'm old. I have three kids, 15, 11, and 9.
Good. Just set up a good example for that, right? Marquis Bariso.
You could just call me Mike.
Mike.
I have no idea what I'm majoring in. I decided to take this class because it was worth a lot of credits and it looked like fun. My chemistry background is my senior year of high school,
Mhm.
which was about a year ago. I took AP chemistry and I got a 4 in the AP exam.
Okay. Good. Good. Julie Cordero. Cordero.
I'm taking this class because it's a pre-rec. I plan on majoring in dental hygiene at a different school, but JJC doesn't offer it, so
Right.
I have to go to probably COD. Last gym class I took was in high school, and I haven't been to high school since 2005.
Oh.
I have a 1.5-year-old, so I haven't been to school since probably 3 years because I was pregnant and then I had her, and now I'm going to school.
Okay. Michelle D.
Yeah, I'm a nursing major, and I took chemistry in like my sophomore year of high school, and I enjoyed it quite a bit, so it's a requirement.
Okay. Andrew Gariti.
Planning on majoring in engineering, and this is a prereq for all the engineering courses, so that's what I'm thinking.
Some science class, huh?
Yeah.
So Salvador Huter.
Last time I took chemistry was in sophomore year, but I'm gonna major in computer engineering, and this is prerequisite as well.
Computer engineering? Prerequisite. Oh, that's interesting.
Yeah, I thought so.
Patricia Hughes.
Hi, my name is Patricia Hughes. I'm taking this class because it's a part of the degree requirement.
Yeah.
Planning to major in chemistry. My chemistry background is my second class. I took chemistry 100 couple semesters ago.
Oh, yeah. Good.
That's
Good.
it.
Good. Yeah. Jacob Johnson.
Right. I plan on majoring in engineering,
Mm-hmm.
and I took chemistry about 2 years ago, and hopefully trying to transfer to a university after this, so it's a prereq.
Good. Your eye has very good engineering, right? Yeah.
Yeah.
Megan Kelly.
I'm majoring in physical therapy at Governor State University, but it's cheaper and closer for me to come here for this. It's a prereq for the doctorate program there.
Yeah. Okay. Yeah, that's good planning. Samantha, Kelly?
My chemistry background is just chemistry 100
Mm-hmm.
here. I'm a medical laboratory technician major, and it's required engineering.
Okay. Ashley McLean. Ashley? Joe Manarez?
Joel,
Joe?
I'm an engineering major as well. Just like almost have a class. Same chemistry as a prerequisite, you know.
Okay. Christopher Nero.
I'm a nursing major. I took chemistry my senior year in high school, and I really enjoyed it, and I'm taking this because it's a prerequisite.
Okay. Don Neverman.
Here. I'm trying to get into the dental hygiene program, and I have a biology degree with a chemistry minor, but it's old, from 2001, so I have to retake the science classes because they're too old.
Usually like how old is it already? Two, okay. When fine.
I majored in engineering. I just moved to this country and I learned chemistry for 5 years, but I didn't accept the record, so I had to learn again.
Oh, you just ask them to do the translate.
And they don't accept it.
Okay, Jack Richard.
Right here. I'm Jack Richard, and I'm a biology major, and I'm taking this class because it's a requirement.
Okay. Elizabeth Romero.
Romero. I took chemistry 100 last year. I don't know what I want to major in, but biochemistry seems interesting, so this class kind of helps.
Very good. Carson Slater.
I'm an electrical engineering major, and I'm taking this as a prereq. My chemistry background is I took AP Chem in high school and got a 4 in the exam.
Okay. Samantha Stegerman.
I'm also took chemistry in high school, my sophomore year, and I'm doing a bio major here, but I'm going to transfer, so this is also required.
Yeah. Okay. Benjamin Tyler.
You can just call me Ben. I think I took chemistry sophomore year. This is just a prereq for computer engineering, so that's why I'm taking this class.
Okay. Maggie.
Maggie, I took Chem 100 last semester, and then I also want to study chemical engineering.
Okay. Chemical engineering. All right. I think Jack, right?
Brad. I'm Brad. I took chemistry in high school as well. This is a prerequisite for mechanical engineering, so fun too.
Okay. Anyone else? I think that's Brad. We have, let's see, one student actually not here today. Yeah, usually, I think by the second week you will have a clear picture.
Cool. Thank you.
Any questions? All right. So I will start on the Chapter-1. So as I said, we are going to have 11 chapters. Usually I will just run the Part-1 and lecture notes, and when you have those examples, I will do the example, and then we will do the CIE together. Alright, so the first chapter is about measurements and problem solving. That's really the basic of chemistry class. So chemistry, we first define what is chemistry. Chemistry is the science that seeks to understand the behavior of matter by studying the behavior of atoms and molecules. So chemistry is sort of central science because it studies the materials, and a lot of science class use materials. So then, what is atom? What is molecular? Those are the very fundamental, we call them particles. Atoms are the sub-microscopic particles and are the fundamental building blocks of ordinary matters. So as I said, ask you like if you don't have the chemistry too much before, but you probably at least know some of those atoms' name or the element name, right? Like hydrogen, helium, and lithium, boron, beryllium, and so on. So some of those atoms very stable. They like to exist by themselves, like those noble gas atoms, helium, and neons. But most atoms are not that stable. That means they are reactive. So when they reacting with each other, they might produce ionic compound, maybe produce ions, maybe produce molecules. So what is molecular? Molecular are two or more atoms attaching together in a specific geometric arrangement. So you can see the word will have two or more atoms attached together. Attached, that means they will stuck together most of the time if you don't let them go through the chemical reactions. If you take a 2H atom, 1H atom, 2H atom, and you bond in with one oxygen atom, so you stack these three together, you produce a water molecule. And then these three atoms, most of the time, they will stuck together, unless you use some methods to break them apart. So then what we use, or what those H and O use to stuck together? Well, that's nature, nothing really mysterious. They use the plus and negative electrical charges. So we know the fundamental force is the electrostatic attractions, that's one of the fundamental force. Okay. So you have to pass charge attract to the negative charge. And those attractions between the plus and negative come in different shape and different strengths, different pattern, different way. So that makes the molecule come with different shapes and different patterns. Right. So now we want to see how we study those materials. We study the material by use the scientific method. Okay, now scientific methods, I think a lot of science class you can study the scientific method. And there are a few of those important terminologies and a few of those process connections, those terminologies. Right? So in a science process, you will start with observation. Right? So observation is the careful noting or recording of natural phenomena. Right? So after you observe something, you make some of those notes or recording something. and you will have sometimes you will have some of those wondering why that happens, or you will probably will try to make a similar observations for some other process. So if you are wondering why that happens, and you will come up with a hypothesis. So a hypothesis is a tentative explanation of a single or a smaller number of observations. Right. So I think the key word here is explanation and a small number of observations. So we're referring to those kind of ideas. Try to explain what you just see, what you just hear, or what you just measured. We call those are hypotheses. Right? So sometimes you observing some of those similar processes. For example, the mass in a chemical reaction. And you are observing the mass of chemical reaction before the reaction, after the reaction. You are observing that for the combustion reaction. You observe that for the acid-base reactions. And you all come up with a similar conclusion. And then those similar conclusions you can summarize into the so-called law. So this is become a very general observed or occurrence of something in nature. Right. So the science is science. You have those law or have those hypotheses. It's usually not always true or not always 100% right. So you have to do some tests. The test procedure, we call that experiment. So there are procedures designed to test an idea. This idea, to test an idea, that idea referring to either the law or the hypothesis. Okay, it's a procedure you design. A little different than our starting term, the observation. Observation probably you just starting with try to recording something, try to measure something without too much control. So once you just decide really what's your focus, and you just design some experiment, you can control some of those variables or control some of those influence and get a very good design procedures experiment. Right. So then the purpose of those experiments is to test those ideas. Then the results of the test can be either agree with your idea or disagree. So that means you can either confirm your hypothesis or confirm your law. See, the law is right. The conservation of mass is right. So all the chemical reaction conserve mass. And then why that? You see, that is because matter composed of atoms, the so-called atomic theory. And then you just see you can design some experiments. Do we really have atom in all the material? Right? So if we have some of those technology and we can somehow observe matter has atoms in it, and then so we can confirm those hypotheses, those from like some of those initial some of those ideas, but not finally will become non-ideas. Right. So you can the hypothesis, you can see that's confirmed by many experiments, that will promote to a higher level. We call that scientific theory. Scientific theory, it still has this keyword in it. Well, this hypothesis also has this keyword in it. We call that explanations. Now this theory still has a keyword in it, explanation. Now the hypothesis here have another keyword, a smaller number of events or observations. Now here the theory, once you confirm the hypothesis, the same hypothesis many times by many experiments, and then that becomes not only for that few experiments we did, we can make some extension and generalize, and those kind of ideas will be true for some other experiment, even though those other experiments we did not do it yet. Right. So this pretty much is the process of a scientific method. Right. To help us to summarize the scientific method, let's summarize that few important terminologies on the last slide. We can use these few keywords I put in emphasis here. What, why, a small number, and all the events. Right. So as we said before, the hypothesis and theory has a keyword, explanation, explain why something happens. And then the observation and law, and tell you what happens. Right? So for what describe what happens is observation or law. Depending on whether you are observing many events or a small number of events. Okay. So the problem goes like this on this slide. We try to identify those terms we saw in the last slide, and maybe law or observations, or maybe theory or hypothesis. So the first space is for the small number of events, something for small number of events, and something that describes what happens. And we call that is observations. Now this space is for all the events. Maybe that word overemphasized, because you cannot say for all the events, but just for many similar events, and describe what happens. Right? And this is called the law. Now, this space here is about small number, for small number of events, and explain those small number of events. What do we call that? Hypothesis. Hypothesis. Because hypothesis, as we saw in the last slide, the key word, one key word for the hypothesis is explanation. Explanation means just why something happens, or maybe how something happens, is the key word. Right? Right. So then this space is similar, but that means you will apply to all the events and apply all the events, try to explain all the events why that happens. Right? And what we call that, what we call that? Theory. Right? So that's about a few important points about the scientific methods. So we have those process and we have these few important terminologies. Right, so that's what we are our first CRE. And you write your name on the scanner I give you, right? So now you just write your name, then you can just write on the test number somewhere, you write the CRE. So make sure you know that that's for CRE. Right. So we'll start.
Can we use pen?
Oh no, don't use pen. Use pencils. If you need a bottle of pencil, we need to use pencils. If you don't have pencils right now, that's okay. You can just circle the answer on the left note and you can do it quicker.
Okay.
The due like whenever we were finished the chapter. We finish the chapter. Yeah, you can just go. Yeah, that's a good idea. Then you just Right. CRE, which means the classroom. Right, so that's what we mean the CRE. So that's so we started this class. We emphasize practice. So we want to practice right away. So even you need to practice before the class. Okay, so the first CRE is explain the difference between scientific law and in the CRE, or in the answers we call that X. And scientific theory we call that Y. Right? So there's a few key words you saw on the last slide. What do you think? What's the answer?
D. Oh, wait.
C make more sense? C make more sense, right? Right. Because the law tells what happens, right? So the key word is law and observation just tell what happens. It's kind of like a summary. You summarize what happened. And the reporter, journalist, they just most of the time they'll tell what happens. Not like too many explanations. Right. Then in compare, you will see that the scientific theory explain. So explain is about this keyword, or the hypothesis. Right. So I think we know what we want to study. We study material, we study matter, right? We study the behavior of matter by studying the behavior of atom and molecular. Then we briefly talk about how we study, which means we use scientific method. We use experiment, and we design experiment, and in the experiment we test those ideas, maybe observation, maybe law, and then we confirm, then we always going back and forth. So then to make the study a little easier, you want to know you study material, you want to know what kind of material we have, right? So we call that the classification of materials. So we have two ways to classify materials. The first way is to classify material by the physical state. We have three common states, which is very straightforward: solid, liquid, and gas. Right? So you can use all those so-called characteristics of each state and tell the difference between each state. Right? So the common characteristic, the common property of each different state is this few. Okay? It's about their shape, about their volume, about their compressibility, about their flowability, whether the material in that state is compressible or not, right? Whether they have a fixed shape or fixed volume. So terminology, but the answer of those questions usually will be maintain or assuming the containers. So you can apply this to the shape or volume, or the shape maintain, or keep the same shape, or will the shape go with the container, or will the volume go with the container. Right? So then we can have some other answers, yes or no, for this last very straightforward two questions. Are they compressible? Are they flowable? Then we will add in this three states, and then you will have this few space here, and then you will see what are the answers. Right. So what do you think? What is the shape of solid and volume and compressibility and flowability? Is the shape of the solid will maintain or assuming the containers? Maintain. Because that will not change the shape. The volume is also maintained. Right? You put like a certain volume of a solid material, no matter where you put that, you will have that amount of volume. Alright, and then some of those are common sense. Quick review: is the solid compressible? Not compressible. Is solid flow? No, cannot flow. Right? So then similar, you will see liquid. What about the liquid shape? Assuming we'll have a container that, very like flexible. About the volume, what about the volume? If you have some liquid, that will maintain. Right? Yeah. And is the liquid compressible? Not too much, right? So not compressible. That will flow, that for sure, right? Because that is liquid. Liquid, so therefore liquid and gas together are called a fluid. Right, gas shape as like the shape of the liquid, or assuming the containers, right? And also the volume, because gas volume can expand and can compress. And the others, I think that's probably the only state it can compress, right? The gas can be compressible. Why that it can be compressible? Why you can compress gas? Because you take the container. What will happen when you compress? When you compress, yeah.
Just like based on temperature, like the molecules are either closer together.
Yeah. I like what you say the last word. Depending on the temperature, whether the molecule is closer or far, right? So in gas, the molecules are far away. There's a lot of empty space between gas, molecular, or maybe atoms. In solid and or in liquid, you might have a molecule, you might have a atom, right? Or you might have even ion, right? So they are very close. They are already like kind of in contact with each other, right? So therefore, there's not too many space between those in solid or in liquid. Yeah, so that's just how far they are away. In gas, they are far away. Right? Right. Any questions? Okay, so the first way to classify matter, I think that's relatively easy. Now, the second way to classify matter is about compositions, and that's usually not that straightforward, especially for at the beginning of a chemistry class. Maybe at the end of the chemistry class, or after you study like a few chemistry class, that becomes relatively easy, right? Because you have to know the composition, which means what is in it. That means type of particles. As I said before, this particle equals atoms, molecules, all ions. Okay, all ions. So those are our usual terms. So when we say particle, the particle means referring to any of those. So therefore, at the beginning of chemical class, you don't know too much about those particles, right? Especially, or you know like those periodic table, you have those elements, but you don't know like those molecules too much. Then what are the arrangements? What I mean, so which is bonding to what? Is H bonding to O? Is H bonding to C? Right? Or O bonding to O? So those are arrangements. And even more like complicated that you study some other one. I mean the more chemistry. So there's different arrangement. And then the attractions and attachment between the particles. That means you have that between C and H is a covalent. Between sodium, right? So those different attractions which mean chemical bond. You can have a C carbon and bonding to H hydrogen, and that we call that covalent bond. Right? So we'll study those in details, right? Because these two atoms share a pair of electrons. Right? Or you can have a sodium atom reacting with chlorine atom, then after chemical reaction, so this become plus, this become negative. Okay? And then this is sort of the ionic bond. So you have you see clearly those electron transfers, or you will see clearly those ions in the material. When I say clearly, that means after you have those after you study few like those chemical class, you know like what kind of material has what in it. So therefore, this topic of the classification according to the composition at the beginning is not that straightforward thing. Right? So now we will start with some matter. So we have some matter in the universe. Then we'll say, what is this matter? Is that you can have like a lot of different like conclusions, but in this class we think about these four possibilities for right now. Later on you have more details. So we'll see right now in this chapter, this section, we'll see material can either be elements or compound or homogeneous mixture or heterogeneous mixture. So that's kind of like a four group of material for right now. We are going to classify any materials. Yeah, so that's true for pretty much any material in the universe. Maybe not all, pretty much all. Maybe 99% or 90%. So those you can belong to these four groups. Right? And so then you ask like a few questions. Or we can use elimination. We will first say this one or that one. Okay? If not this one or that one, belong to the other two. Okay? And so what I like to use for the first question is does it have only one type of atom? The book has a little different question, but so that's probably not that straightforward. So I like to use this because we study the material, we study atom and molecule. So therefore, let's go on like about atom right away, atom and molecule right away. Right? So does it has only one type of atom? Well, there's well, in general or roughly, there's only about atom type, about 117 different types, and that is summarized in the periodic table. Okay? So this is our different type of atoms. I said roughly in general, you have 117 different types of atoms, but if you see in details, there's even more than 117, because you have a different type of carbon atom, and we call that isotopes. If you forget about isotopes, so therefore you see just all the carbon are the same, that's one type. All the like the silicon are the same, so that's another type, right? But when we study chapter 2, we'll see we have carbon 14 isotopes. So this is something for example. For example, carbon 14 and carbon 12. So they are a little different. They are a little different. Chemically, little different chemical reaction rate. Maybe go through the similar chemical reaction, but maybe go a little slower or a little faster. So that's about isotopes. And so then, if you have some material, you just think about what you can find in the material. Can you find the helium in the material? Can you find the hydrogen in the material? Can you find the oxygen in the material? Okay? If you can only find one type of those elements in your material, then you know for sure your material is element. Right, so therefore, if the answer is yes, our material, our matter is element. Okay, for example, in this aircraft, not the aircraft itself, but inside the aircraft, those gas, right? And those are helium. So that helium, you imagine inside the fuel, there's only one type of atom. Only the chemical symbol of that is He, helium. There's only one type of atom in there, right? So what kind of material inside the aircraft? This is an element. If you know, so as I said before, you can use elimination. If you know this, that means all possibility, all the other three. Now you have to make a difference between the other three. Okay? Therefore, you know, we'll say that belong to compound or mixture. Right? So now at least we ask one question. Does it have one type of atom? We get these two groups, this subgroup, there is more in that group. Right? Now let's see the second question. So we want to tell the difference between compounds and mixture. Okay? So what we do is ask this question: does all the different type of atoms combine into only one type of molecule? Because if your material belongs to this group of materials, that means it has more than one type of atom. If there is only one type of atom, not belong to that, but belong to this. Okay? So therefore, you have more than one type of atom, maybe 2, maybe 3, maybe 4. So that's the question you are thinking about. Use your previous chemistry knowledge. You have hydrogen in it. You have oxygen in it. Okay? Then you think about, do all the oxygen and all the hydrogen combine together, no leftover? And do they all produce one type of molecule, not only one molecule, but you can have a lot of molecules, right? If yes, and then you have a compound. Otherwise, you have the mixture. Now the key word here, so key word here is one type of atom. One type of atom. Okay? Now the key word here for the compound, is let me rewrite, is one type of molecular, but with different types of atoms. But not become a key word, but become a key sentence. Right? So what is a compound? Compound is molecular, one type of molecular with different type of atom. You cannot only use, so, I mean, there are a few words in here, right? Molecular is one word, and then different type of atoms is other words. So therefore, you cannot only use one part as a criteria to selecting whether your material is a compound or something else. You have to think about or try to memorize all those words here. Okay? Yeah. All right. Any questions? Okay, so if no, let me read this. You can see in this example, you probably familiar with our methods. So we use different color of bars representing different type of atom. The red one is representing oxygen. The white one representing H. Right? So now, if you don't see this result, you will see if I give this material, you ask the first question. If this material has only one type of atom, no, we have red and we have white. So therefore, it's not two types. If you have two types of atom, your material is not an element. Okay. Now the second question: does all those oxygen and all those H combined together produce only one type of whatever, model or the molecules? I'll say yes. You see all those molecules here is O and 2H, the one O, one red, two white, right? And those some of those in the background just give you those perspectives, but pretty much they tell you in this picture, all the H, all the O produce only one type, is H2O, right? So that's a good example of compound. This is a mixture, right? Why that is mixture? And again, if you don't have that answer, if I give you that picture, you just ask the first question. In that picture, do we only have one type of atom? No, we have a different type of atoms, right? If different type of atoms, therefore, is not element. Not an element, you can possibly have a compound or mixture. So which one is that? Is it compound or mixture? And usually that easily get confused. Okay? Compound, which means only one type of molecule with different atoms in it. And otherwise, you will have a mixture, right? And in that one, you can see we have some of those water molecules there, right? H2O, and we have some of the other little larger complex molecules, the other molecules. So clearly we have at least two types of molecules, which is not a pure compound, not a compound. It's a mixture of compound, or maybe mixture of compound with elements. I think that's about it. Okay. I overclick. What is this? This picture belongs to what? It's a gas. Very good. That's good. That's good. It's a gas because you can see like there's a lot of space between those, so we call them molecules, right? What kind of gas? Is a gas element, or gas compound, or gas mixture? Well, all together. Yeah, all together. This is one element, right? And this is one type of element because in this, if you don't have that two, only have this one, and there's only one type, even though these two types are together, but there's only one type. But both is red, right? But you have this, so this one pair, two other pairs, so this together in this picture, that is what? Mixture. Yeah. Mixture of what? I say mixture of compound or mixture of elements?
Compound.
Mixture of elements, right? Mixture of two elements. You can see more like in details, mixture of two type of elements. One element is this type. Even though you have three element example, but you just see this is just two type. So one type, you can call this oxygen O2. And the other type is H. Right. So we go by the types, not how many. You go by the how many types, not exactly how many molecules or atoms. Right. So again, this is a mixture of two types of elements. Alright, so right now we have these three groups now, right? Because we asked two questions. Our first question will pick up this element. If your material has only one type of atom, your material is an element, right? Otherwise, your material may be compound or mixtures. Our second question is that our material has more than one type of atom. I have more than one type of atom that all those different type of atoms combined together produce only one type of molecule like water. If the answer is yes, then we have a compound, right? So then, you know we have mixtures. And then I think that's it. You can just so the level 1 is a mixture. So we have mixture. Then we will see the details of mixture. We have two types. Either heterogeneous or homogeneous. Homogeneous. I think some people say homogeneous, but I usually see homogeneous. Right? So homogeneous and heterogeneous. Well, they just say like it is uniform throughout. But uniform or not, that's not really a sharp cutting line. So usually I will say you can just use your naked eye to say like whether there's difference or not. But that's not always true because there's some other, some material called colloid. So you can use your naked eye, cannot see the those particles like when you go to a forest tree, you see the sunshine, you'll see the path of the sunshine, and that's because the sunshine goes through the material called the colloid. It's kind of those particles floating in the air. Right, so we don't have to worry about those in details. So we will just say uniform. We'll see like with our naked eye, right? And we see if we can see clearly there's one region. If you pick up a rock, you'll see there's a rock. When you cut in a tree branch, you will see there's obviously different regions, different circles, right? So that if yes. And it's homogeneous. If no, it's heterogeneous. Right? So that means in a long run scale, if you observe here, if I just give you this picture, you can see this uniform probably will not that totally agree, but this part has more sugar. That part has more tea or something, but so those are kind of like random in their area. We don't have to worry about that for like those mixtures. Now that's really clearly tell the difference. You have that the top part and then the bottom parts. Clearly there's very different, right? And then we see that, if you think about again the top and the bottom together, and that's you have two different compounds. On the top, you will see those are the waters, right? And at the bottom, there will be the sand. So therefore, put together, that's a mixture. Right. Now, you can have these four like a smaller group, and actually these two together belong to a different larger group. We starting with on the top is the matter. Matter, we have these four small groups, and each of those can have more details, more small groups. So going backward a little bit, so together element and compound, we call them together, belong to a different larger group, we call them pure substance. Right? So that's all we like to study that. So we adding we go backward a little bit. We adding like one group or one layer after the material. So material you can think about now. These two types. These are pure substance, and obviously that two together called mixture. Right. So depend on the the topic, depend on where we use it. So we use different terminologies. So sometimes we'll call them pure substance. We don't tell the difference between element and compound. Okay? And we'll call them just mixtures. But sometimes you want to see like more details. You'll see, do we have an element? Do we have a compound? Do you have a mixture? Do we have a homogeneous or heterogeneous? And later on, even more details, you have the element. What kind of element you have? We know element has only one type of atom, but atom can exist by themselves like helium, or atom like oxygen atom and hydrogen atom. They bond together produce a molecule, right? And the compound also have details as I showed you before. Sodium chloride is an ionic compound, right? And there's some of those methane, the coating gas, the CH4, they call the molecular compound. Right? So right now we have this few terminology. We have the mixture, and we have pure substance, and then we have element, compound, and heterogeneous mixture, and homogeneous mixture. Right? So summarize, element again. It is made of one type of what? Atoms. One type of atoms. No matter what is the arrangement of the atom. What I mean, do those atoms exist by themselves? Or those atoms, few of them combine together to produce a molecule? Or maybe all those atoms in your material combine together produce a gigantic molecule. We have those. For example, diamond. In diamond, there's all carbon. And all the carbon is bonded together is a large molecule. And little small molecule is like sulfur. If you have a piece of sulfur, and actually sulfur, not all those atoms by themselves, like 8 atoms together produce like a cyclic structure. Right? So that's, and then we know that the different elements combine together to make a compound. So most of the atoms like that, except that noble gas. But more than this, even the noble gas, we even use noble gas to make some compound. Right? So there's one example. In this example that we saw before, right? There's only one type of atom. All of them are helium. And in particular, all those helium, do they combine together or they just exist by themselves? They exist by themselves, right? I think I'll have another example. What do you think of these two? What do you think of this one? In this picture, what is this? Is this a compound or mixture or element? Element. Right? Now this element is a little different than that element, right? Or the element I showed you before. This is also element. I should ask you first. This is also element. I think that's straightforward, right? This element because in this picture there's only one type of atom. All here is red, right? And this element is also element. Even though this here you have all those blue bars here just stuck together. But if you ask, remember that the question, the first question is that your matter has only one type of atom. No matter your atom exists as a pair, as a triple, as a quadruple, as a gigantic diamond molecule. So the key word is one type of atom. If you have only one type of atom, no matter how they exist, it's element. So therefore, this is also element, right? And this is what? Also element, right? Now see here, later on, you see, this is called what? Molecular element, and this is called what? Atomic element. That's very straightforward. Molecular element, which means the atom exists, the same atom exists as a molecule. Atomic element means the same atom exists as individual atoms. Alright. So I think we'll finish this slide, we'll take a break. Compound has how many type of, you probably don't know the answer, but just tell me like roughly. Compound has how many type of atoms? At least 2 different, right? 2 or more different type of atoms. But have how many type of molecule? One. But that one type of molecule must with different type of atoms, because otherwise you'll go back to the element. So middle one type of molecules of 2 or more different kind of atoms, or array of ions of 2 or more different kind of elements. Right, so I think we saw that before, right? Now this paragraph here just tell you sometimes we have that molecular terminology, not like for everyone. As I told you before, yeah, there's different like type of matter, like what I said, ionic compound, like NaCl, right? Well, it's still the same, but we just use different terminology. So you will see like some of those you call that not like molecular, you call them unit, right? So that's about the compound. So I think you can pretty much everything is compound or mixture. So then you have the mixture. You can either heterogeneous or homogeneous. Well, we know that if it's mixture, that means it has more than one type of pure substance, right? What is substance again? What is pure substance? Pure substance has 2 smaller groups, right? What have? Yeah. So we have a mixture. So you can either mix 2 different elements, or you can mix 2 different compounds, or you can mix that's 2. You can mix 3 of course. Or you can mix 1 compound with 1 element, right? Now in the homogeneous, that means all the portions of an individual sample has the same composition and property. Right? So tea with sugar, if you see the tea with sugar, if you don't put too many sugar, as all the sugar dissolve, if you put too many sugar, then at the bottom of the curve, you will see the sugar, then you will have the heterogeneous, right? So if all the sugar dissolve, and then you can see that it's pretty much, everyone are the same, every part is the same. On the top, at the bottom, you will have the same compositions. Right, so then again, the wet science, so you have that wet on top that's just clearly different than the sand at the bottom, right? So you can tell the difference between different part of the material or different part of the sample. Alright, I think we'll take a break, right? So we usually will take a break of about 8 and 5 minutes break. Right. You have the book, but I didn't, well, see how it goes.
Let me see who needs a guide or can you get flyers?
I think it's unless you can borrow your friend, I think you have the book and read the book, and also do the quiz at the end of each chapter. There's self quiz. The quiz are very good for study for the final exams, and also study for the exam I will give to you later. Yeah, the 2 exams I give to you have 30 questions, but the final has 70. Yeah. 1 hour 30 minutes. Just normalize. So we have 30 total questions, right? So whatever you get, you get 27.
How many points
Yeah. Yes. Yeah, for each exam.
100 points?
200.
For each exam?
Yeah. For each exam. We have 3 exams.
So it's 3 points each conservation question. 3 points. Hey, I looked at the first quiz and one question was probably wrong, the answer was
Really?
yes. You know the multiple choice question?
Yeah, what was
That was A and B choice,
Yeah.
and it's B and C questions. It's 9 or 10.
Okay. Let me check. I think that's.
I want to email you, but there was no email on the website. And then I think that's
School chemistry together?
I know what I did today. What do you?
I will look before I take the class.
No, I used to.
Okay.
Other classes, in my alarm manual, that was just too much. So I was like, I'm so excited to hear this again. Because like, the idea is I was like,
That's where it's at.
I'm gonna make it work.
No, I wonder. Okay. This year they made it into like shopping center this year.
You know, you like go up there and like,
So that area is like sure about this there. Now I'm back here. Yeah, long way to go. I got the winter coming, I'm gonna get going. It's like so cold, it's like 20 degrees, so it's 50.
I know. Well, just for the specific school. I was, it's really cool with our kids. Since I've been looking, it was 5 years and then they changed to 7, so I figured that would be
Okay, so let's continue on Chapter-1. Alright, so this slide summarizes that 3 questions. So the first 2 questions will tell the difference between the elements, compound, and the mixture. And then the last question will tell the difference between the 2 different mixtures. So the key word for the first question is one type of atom. And the key word for the second question is one type of molecule with different atoms. Make sure you think about the molecule as one type, but also see those molecule has different atom in it. Because otherwise, you have a molecule, but in the molecule there's only one type of atom, and even though you have a molecule, but they still are elements. So then the last question is about whether you see that uniform or not, and some of those materials you can see very easily that are not uniform. In the lecture we see those wet sand, and some other like concrete, wood, right? So most of the material in the universe is mixtures. And then you erase this, we'll do a few practice. So we'll identify, this I get from your textbook, page 34. Okay? I think it's a good idea to do those homework assignments in the textbook. So I will give you the list of the programs. So I will like post one file on the canvas. So in addition to those to the CRE questions, and you do have those at the end of the chapter. There are some those exercise or programs. So this is from textbook page 34. Right? So let's see, what is A? We have that four, right now we have that four terminology. Element, compound, homogeneous mixture, heterogeneous mixture.
Compound?
The compound, right? Very good, very good. Super good. So this is compound. So we first use our first question, right? The first question is, does it has more than, does it has only one type of atoms? No, there's different type of atoms. Therefore, not element, right? So then you ask the second question. So now we know we have a different type of atom. That all those different type of atoms combine together and only have one type of molecule. Yes, so all those has those kind of arrangement, those kind of shape, exactly the same. Right? So therefore, it's a compound. Right? So what do you think about, let's say, go B? What do you think about B? So remember that's three questions. Right?
Mixture?
Yeah, that's a good. So it's a mixture. That's it, right? Why is a mixture?
They're not even. They don't have the same amount of balls.
Well, okay, yeah, that's. So we still want that three questions, right? Do we have more than one? Do we have only one type of atom? Oh, we have like two type of atom, right? We have two type of atom. Yeah. So therefore, we are not elements. Now you have to see, those, not element, that means you possibly compound or mixture, right? And the last one is a compound because you have, you see, that's very similar. So all those combine in only one type, right? Now here, atom by themselves, right? So they do not combine together to produce any molecules, right? So therefore, we know that's a mixture, right? It's a mixture of what with what? A mixture of element with element, or a mixture of a compound with compound, or a mixture with element with compound. Element with element. Right? So it's this element mixed with this element. You get some point. I cannot. I think it depends on what we say. This scale. I think this is on a scale of atoms. You probably cannot see that in the heterogeneous. As I said, those on a scale of atom, you not really can see that much uniform. Even like with I can just say that's for sure that is a mixture. But if you want to argue that heterogeneous, because not evenly, maybe here there's a little more one element, there's a little more that element. But when we like decide whether it's uniform or not, you don't have to go to the small scale like this. You don't have to think about on the level of atom or molecules. Right? So I think that I prefer to say this is homogeneous. So if I see this heterogeneous, or put like one here is more closer than the other part there is a little far away. So you can see that one is gas, the other is the liquid. So then you can see very clearly you have the heterogeneous. Right, any other questions? Right, so what about C? C is what element? Element mixture, that's good. Because a mixture of elements, right? A mixture of elements, very good. So this is what you call those. If we don't have those, we only have this type, and this is one element, right? So if we only have this, if I only start with those guys, right? Only have those, and this is only one element. Even though we have like two atoms together produce so-called molecular, but this is still element because this just just like one type of atom. Now, if you do the same to the other one, if I sort of flow this, and this is also what? That's also element, because in those, you only have one type of atom. Right? But if you put these two together, and obviously together we have more than one type of atom. We have this atom, we have that atom, and all those atoms do not mix like that, produce like only one type of compound. So you still has, and this may be oxygen, O2, and that may be, this may be hydrogen, H2, right? So that's one possibility. So this probably equals O2, right? And that probably will be equals H2, so O2 and H2, right? So you still have those H2 by themselves and O2 by themselves, and they don't combine into something together one type. Very good. So this, what we say, this is a compound, and this is a mixture of two elements. And this is the same. So this C is also mixture of two elements. Right? You've already seen about a D, right? So what is D? It's a mixture of what? Very good. Yeah. So you, again, just you can, if you cannot get the answer quick, you just say, do we have more than one type of atom? Yes. We not only have one type of atom. If you only have only one type of atom, like we don't have that. If you only have one type of atom, I mean you have that. That's all. But if you only have one type of atom, you have just element, right? Right. So those are one type element, and those kind of combine. But there's some other type. But other type already combined with this. So this, one of this is a molecule of compound. Agree? So this one of this is one molecule of one compound, or one type of a compound. And all these here compound are the same. It's the same compound. Right? But this is not a compound. Right? So those are elements. Right? So therefore it's a mixture of a compound with one element. But a mixture of one, you don't perhaps don't see that, only one type or one element with one type of compound. Right. So I think that's, if you emphasize that three questions, whether you have one type of atom, whether you have one type of molecule with different atom, so that will give you the element or compound. So we use these two questions to identify element and compound. Then if do not belong to element, do not belong to compound, it will be mixture. What do you think about this? Usually the following is not a pure substance. Remember the pure substance equals either or, right? Either element or compound. Right? So you think about those materials. Water has H in it, you call that H2O. Carbon dioxide, which is CO2. Carbon, that's C, that's carbon. Air,
that's nitrogen, H2O.
Yes, very good. You have a nitrogen, N2, right? That's probably like 78%. And you have O2, oxygen, about 21%. Yeah, probably not too much hydrogen, probably somewhere I think that's some of those argon and maybe some of those, water vapors. All right, so what do we think? So that will be our second one. Why don't you can just circle the answer on the regular notes. So later on, the due date for the CRE is the date when we finish the chapter. Okay? So whenever we finish the chapter, you turn in. So I just say don't be late. If you are late, if you are not here, or you are late when we finish the chapter, so the CRE is not acceptable. Okay? You have one, you can draw one CRE. If you forget the one CRE you did not turn in, and so everyone can have one, can draw the drawers. Right. So pure substance, or not a pure substance. Air, not a pure substance, right? If not a pure substance, that means right now we have these two groups, either pure substance or liquid, right? Air, usually the air you can say is what kind of mixture? Air is heterogeneous or homogeneous? I think most of the time the good quality air is not heterogeneous, right? Homogeneous. Right. Which of the following is I give you this picture, right? So you saw the picture before. So identify what kind of material you have. We're also adding that state. So you are telling me what is the state?
Liquid pure substance.
Is that carbon dioxide?
Yeah, possibly that's, you can say that's carbon.
Pure substance.
You can see that pure substance, right? Pure substance. But what kind of pure substance? We can have a good, very good idea about the state, depending on how far away those molecules or those atoms. Usually when you draw the liquid or the solid, so you pretty much those are one touching the other one. If there's no touching, you're kind of far away, is one state. It's a gas, so that's a gas. Alright, so the answer is what? Together, the gas is pure substance, right? Yeah. The answer is A, right? Right. So chemistry is about behavior of matter, and the behavior, that means how the matter change. And while that change, usually in chemical class, you probably will see most of the change of the chemical change, chemical process. So therefore, we study different type of chemical reactions: acid-base reaction, combustion reaction, oxidation reaction, precipitation reaction, and so on. Right. So right now, let's in this chapter, what you see is the change chemical or physical, or is a property chemical or physical. So we emphasize those chemical bonds. Changes that alter the state of appearance of the matter without altering the chemical bond are called physical change. Then obviously, if you think about some of the process that has some of those chemical bond change, okay? And then you have the chemical change. I think you should be able to, identify some of the fundamental process, whether you have the chemical bond change or not, if you know what we studied in the last section. In the last section, you know how to tell the difference between elements, right, and compound and mixtures. Okay? If in the process, if you don't produce some new substance, and in some process, so you will have the physical process. Because whenever you produce something new, right? And you are making some new chemical bond. Okay. I think we will see some example. From the example, you will see the chemical bond change, right? Or not change. Right? So if you don't have the chemical bond change, your process is a physical process. Okay. So I have this few example. You want to identify the change. So I will first with the starting material, or we call that a reactant. Okay. So our starting material here is H2O liquid, okay. And usually we call that starting material is our reactant. Reactant or reactants, right? For this one, we only have one picture here, right? And this is only water in it, okay? So the pure substance. Okay? Now let's do a little more than what we see in last section. Last section we just say you have those molecular. Now you can see those all the molecules together. So molecules together, you have O have H, which means you have a chemical bond. So the chemical bond between O and H and O and H. And that's the only bond we have right now is the bond between O and H. Now let's see the other change, other process, and what becomes that? Become H2O gas. Now H2O gas, you can classify that material is still a pure substance, because in that picture, you have more than one type of atom, not element, right? And all those different type of atom, H and O, I should say, is a compound, right? The pure substance, like not that to the point, right? But so that is a compound, right? So this compound is still a compound, and we still have the same compound. We still have H2O. So therefore, in this process, you go from this liquid to the gas. We did not break any chemical bond because of old chemical bond. We did not have any. We did not produce a new chemical bond. We saw the new bond, right? Right. So we don't have any chemical bond change. If you examine the process like that, right, whether you have a bond break or whether you have a bond produce. Usually these two will happen together, right? If you don't have that, your process is a physical change or physical process, right? So therefore, this is what process? Physical process. Right? So now we have two reactants. We have this one and this one. What kind of material is this? What kind of matter is this? Is this matter element, compound, or mixture? Or element. This is only one type of atom. Only one type of atom. Even though there are two atoms together produce a molecule, but that molecule has only one type of atom. Right? So this element. What about this? Element. Okay. Now you have the chemical bond. You also think about the chemical bond here. So what is chemical bond here? Right now you don't have to tell, right, in more detail, you don't have to tell double bond, single bond, triple bond, ionic bond, covalent bond. You just say what bond to what. Now here is two red bond to red. Right? Now here are those yellow bond to yellow. Right? So those, for right now, I just want you to tell that. You see what bond to what. You don't have to worry about use ionic or covalent. Right. So this element, and that's also what? That's also element. Because in that picture, there's only one type of atom. Right? Now let's see what happened, what it looks like after the process. Think about the bond, right? The bond here is red bond to red, and yellow bond to yellow, no like yellow and red. And here you have, you see here, even though the bond, as I said before, is here not really those bond, you also those ionic bond, right?
Chemical.
It's a chemical process. Because you break some of the bond. You break this O to O, or red to red. You break some of those yellow to yellow. And you also, you will have it together. If you break, you will produce. You produce those new bonds between the red and the yellow. Very good. So if you see those chemical bonds change, so as you study more and more, you will know more and more. So we can even calculate how much energy do we need, thermodynamic, right? And we can even, like in later chapter, we'll even know more details. What type of bond break? Do we break a pi bond? Do we break a sigma, and so on? Right. So this is a chemical process. And now we have another two reactants, maybe two reactants, but if you read a chemical reaction, call it reactant. But so we have these two starting materials. So we have this is looks like what? What kind of matter is this? What kind of matter is that? Both of them are compound. And so this is a compound. I think that's you're probably familiar with this H2O, right? And that is the compound. We looks like the type of sugar, sucrose. Sucrose has like the so-called disaccharide, has two those monosaccharide, one is the sucrose, one is the glucose, the other one is the fructose. So one is the fructose, one is the glucose. So both of them has a six atom ring. And bonding together with another single bond. So it looks like in very good range. You see here like 1, 2, 3, 4 sucrose, 1, 2, 3, 4 sucrose. When you see those kind of structure, you call those kind of structure what kind of structure?
Solids.
Huh?
Solid.
Solid, very good. Solid, and one particular solid. What would we call the particular solid?
Sure.
Right? Yeah, those are the carbohydrates, sugar is carbohydrate. What solid is this? Remember we have the amorphous solid, which means you don't have any odor, right? And this is kind of not that important, that's a crystal, right? Crystal. This is the that when you see the sugar, table sugar, you see those shining table, right? So those crystals, right? So again, this is pure substance. This is also pure substance. And in particular, this pure substance is a compound. This pure substance is also a compound. So you have two compounds. A compound has a chemical bond. So I said you don't have to worry about those. What is the name for the bond? You will see that here you have O bonding to H, right? And here you have those H bonding to carbon. So that's what we call it carbon hydrate. And then you also have O in it. Right? So remember those few bonds in the beginning. And let's examine the bond after the process. Do we have any new bond? Probably that's very easy to say, right? Do we have any new bond or any new molecules or new atoms? No. We still have that sucrose, and we still have those H2O, right? If you still have the H2O, and you still have the sucrose, you don't have anything else, that means we don't have a new chemical bond. If you don't have a new chemical bond, according to the conservation of mass, that means you don't break any chemical bond. Right, so what process is this? It's a physical process. That's a dissolving, right? Right. So that's and what do we have here again? What kind of matter is this? Element. Maybe gaseous element. Right? So what kind of material we have here? Yeah, very good. That's compound, not element. Right. So we have elements with compound. Okay. Now again, you just think about what bonding to what. What is connecting to what? So here I have red to red, and here you have that. So those are the H, and those are the image side. Those are carbon. So we have carbon H and carbon H. Okay. So this is actually the we call that protein. Right. So in one of this, so you have a 3 carbon in this, and you probably see that 3 carbon, right? See the 1 carbon, 2 carbon, 3 carbon. And carbon usually those double phase atoms. So those are carbons. Now those small guys, those are H. So you will have something like this. So this sort of protein. Okay, now you will see the bond between this in this molecule. You have a bond between carbon to H, carbon to carbon, carbon to carbon, and so on. Right? So you have these few type of chemical bond. Now this guy is our oxygen gas, our element. So you can see in this. In one of this, you will have the O bonding to O. Actually a double bond. Which means there are 4 electrons in between 2 oxygen atoms. So that is that are 2 rectangles. And now let me erase that. See what happens after the chemical reaction. After chemical reaction, we still have those. We still have those red guy, which is oxygen. We still have those black guy, which is carbon. We still have those guys, which is the H. Now what is bonding to what?
Chemical?
That's a chemical process, right? So you don't have this guy before, right? And this obviously it will give you the bonding pattern in this guy. And that means you have the carbon bonding to 2O. And before you don't have that. Right, so that's the chemical process. Right. Now next few slides just repeating what we said before. So the first process we said the physical process, because you change the liquid water into gaseous water, and that's a boiling process. And in the second process, you're starting with some of those 2 elements. Remember, 1 element is iron, those guys, and the other element is O, so 2 red balls. And now you have this called the rust. And you don't have this yellow to the red before the process. Alright, so that comes to the common process. You don't want to use those criteria like the color change, or the smell, or the heat. Those are not absolute. So if you want to see the chemical change or physical change, you just see the chemical bond change. Okay. So that's our example 3. Example 3, we will take that water with table sugar, and so table sugar is a crystal, right? So you put that in water, it looks like it disappears. What happens? This is our solid sugar, and you put in water, so that it becomes solution. But in the process, you did not break any chemical bond. and at the end, you don't have any new chemical bond. So that is the absolutely criteria to decide whether your chemical or physical, whether the process is chemical or physical. Okay, I think the last one is the combustion of propane. Yeah. See here, propane fuel, right? Yeah. So that means you have C3H8, 3 carbon. Right, and this equation representing the chemical process. And if you know the chemical equation, it's very easier to identify what you produce and what you're starting from. So usually we're starting from some of those substances and produce some of those new substances, maybe new compound, maybe new element.
B, that's it.
This is what? B? Chemical reaction. Because we can see we don't have a brown gas in the starting materials. Okay, so you have two possible chemical reaction for this process. You can think about if the concentration of nitric acid, which is one of the 6 strong acids when starting in chapter 4. Okay? So these are very, very important. You have to be able to remember some of those sort of strong acids, and this is one of those 6. Alright. So in one chemical reaction, if the concentration of nitric acid is very strong, very, very high, and that can oxidize the material, like the carbon material, okay, into ions, and therefore you will see that initially carbon is solid, okay, but some of those electrons in carbon metal was grabbed away by the nitrogen atom in the nitric acid. Now here, you still have the Cu, but Cu here is actually not the Cu as before. Before the Cu has all the electrons. Now here the Cu lost some electrons. Right, and so in this process, so we dissolve the carbon, and we produce this brown gas. And if your concentration of the nitric acid is not very high, you kind of dilute it. You initially will produce not NO2, it's NO. But this guy initially produced from this kind of reaction will change into that very quickly in the air. So in the air there's O2. And O2 is also a very good oxidizing agent. So therefore, no matter you take concentrated nitric acid or diluted nitric acid, you probably will see the brown gas. Even though here you produce NO first, but NO change into NO2, and that looks like also brown gas. Now those oxide of nitrogen, maybe NO2, maybe N2O or NO, are very interesting materials. So there's still a lot of scientists study them. In 1998, just about 20 years ago, something, right? So like 3 scientists received the medicine Nobel Prize by studying this guy. They find out this NO is a so-called free radical. Okay, is a very important signal, the cellular signal molecule. You know, like the human body has all those cells, like the white blood cell, or some of those cells. What the cell do? Maybe the cell were antibodies fighting some of those bacteria or something, right? We need the signal. So this angle, they just find out like a few years ago, is a very important signal molecule for the cardiovascular system. So whether you have the right signal or not. Yeah.
No, I have a question. For the, in parentheses, AQ, I know that one's aqueous. What's G in the other one?
G was
G is gas.
Okay,
G is gas. And L is liquid.
okay.
Yeah. S is what? Solid.
Okay.
Right. Very good. So usually we are studying more like more details of chemical reaction equations in chapter 4. Yeah. So you usually will show me the state, whether you have aqueous, 4 common states, and that appears all here. So you have liquid, gas, aqueous, and solid. Right. Any other questions? Yeah.
Is the bottom equation well balanced? Because I don't see 8 nitrogens.
You don't see 8 nitrogens? Okay, you see here is how many?
2.
2.
Six.
Yeah, 6 here. Yeah. But you have.
Oh, yeah.
Yeah, you don't
Forgot
have.
about that, yeah.
2 here. Yeah. Yeah, it's balanced. Right.
C.
See? Yeah, it's like when you toast a piece of bread, yeah, very good. So in bread, in the modern process, they said you should eat, well, I cannot. Well, they said when we processing bread, there's a lot of those add-on. We're adding a lot of those chemicals in it. For example, we're adding like vitamins. We're adding maybe sugars. We might take some of those. We may be adding like fibers. We might take some of those saturated fat out, and so on. But in those food processing process, so there's a lot of problems. I think the best food you eat is without this food processing process. Bread will have sugar and have the starch. If you toast very heavily, and you will see it become like even darker. So that's possibly the sugar will caramelize. So the sugar become carbon, become element of carbon, and then you're starting from all the starch. Right. So then we have those chemical change and physical change. Then the same. You have the chemical process. Chemical property and physical property. Right. So that means what is the property? Property, there's a lot of property in chemical class. We'll see those temperature of the material, right? Density of the material, volume of the material, pressure of the material, concentration, and so on. So if you can measure or observe some of those properties without change or alter the identity of the material, then those kind of property is physical property. So physical properties are you can observe without changing the identity. Well, change the identity, which means you change the chemical bond. If you don't change the chemical bond, if you simply change the state, you probably see like they were different like what we saw in the last equation. You can see something like H2O S, which means ice, right? Change into H2O liquid. So that never change. So they are not really exactly the same matter. So because one is the water solid, the other one is the water liquid. But we see the identity, which means those not really the state, right? So just the compositions, right? So the chemical properties are the characteristic that determine how the chemical bond of matter change as a result of contact with other matter or the influence of energy. So those are the chemical properties which describe the behavior of matter. Right? So let's see some of the examples. Determine whether each change is physical or chemical. What kind of property is demonstrated in each case? So we want to identify are those chemical process or physical process, that's what we did before in the last few slides. And then we want to identify those kind of things they do. We call them property. Maybe flammable, maybe vaporize, maybe was be able to react with something. So determine whether, determine the first one is the evaporation of rubbing alcohol. Evaporation of rubbing alcohol, which means you change something from liquid into gas, and that process is what kind of process? It's a physical process. Yeah. And that also tell you that rubbing alcohol be able to change from liquid into gas, and those the ability is a physical ability, right? Right. I will also give you the answer for the second one. That means the burning of lime oil. Burning of lime oil is same as the burning of the propane. So you will see that it produce H2O and produce carbon dioxide, those are the common products. And those are so the combustion process obviously is a very common chemical process, chemical change, right? So then that flammability is a chemical property. Right. The bleaching of hair with hydrogen peroxide. Well, here is actually protein. Hydrogen peroxide is H2 and O2. So the bleaching of hair with hydrogen peroxide is a chemical. Then the susceptibility or the sensitivity of the hair to the bleach, to the H2O2, the H2O2 be able to bleach the hair is a chemical property. Okay. The forming of frost on a cold night is physical. That is simply condensed water vapor in the air, not condensed. We change that from gas directly into solid. Right? They call the deposit. So you see like that is a physical process. Then water be able to do that. So water be able to change from gas state and directly into solid state. So that is a physical ability, physical property. Right. So let's do some of those properties that describe the way a substance reacts to form other substance. That's very straightforward, so that's the chemical property. Right, so we pretty much finished this chapter, those conceptual part, most of the conceptual part. Later on we study some of those sig features, conceptual too. but in terms of those really conceptual. And then we are going to study some of those numbers, something to do with numbers. So those is called the standard unit, and then we'll see how to convert between different units and so on. Right. So scientists have agreed on a set of international standard units for comparing all the measurements, and we call that system is the SI system. It's based on the metric system. Right. So we have some of those. These few are sort of the basic. Those are the basic properties. Length, mass, time, and temperature. Okay? So we need those in the science class. And the SI unit for the length is meter, and then the symbol is little m. Mass is a kilogram. The symbol for the kilogram is the kg. Okay? And the time is second, and that is lowercase s. Temperature, what do you think? Temperature is what is the SI unit of temperature?
Kelvin, Kelvin.
Kelvin, right? Kelvin. No. Celsius is sort of the metric. So that's therefore, but there is a difference between metric and SI. All right. So then we will see some other. Well, first, let's start with more details about temperature. So we have three different common temperature scales. We have the Fahrenheit, what we use here in US. Then Celsius is also very common. And then the Kelvin in the science class. And this slide tells us we can use these three different thermometers, have those different scale on the thermometers to measure something that's the same. Okay? And so therefore you have those calibration markers, right? And you see like the water freeze point, right? Is so that is definitely the same warmness or same coldness for the water freeze. No matter what you use to measure, because if you measure with your hand, you'll feel the same coldness, right? But if you use different thermometers, then obviously you have different readings. If you use a Kelvin thermometer, water freeze reading will be 273 Kelvin, right? If you use Celsius thermometers, it will be 0 degrees Celsius. Okay? If you use a Fahrenheit thermometers, it will tell you it's 32 Fahrenheit. And then if you increase the temperature of the material, let's say the water, from freeze again into boils, and you will again have the same hotness. You cannot feel with your hand, but you see that in Kelvins it's 373, right? Celsius become 100, and the Fahrenheit become 232. Right. So from those analysis, by observing these three different temperature thermometers, and you'll be able to come up with the next few slides we're going to talk about. Okay. So when I want to talk about is you use the thermometer to measure the temperature. Actually, you are measure the average kinetic energy of the material. The material may be molecular, maybe atoms. And then the average kinetic energy of the material, the atom or the molecular, is directly proportional to the temperature in Kelvin. Right? And so now we also know from our common sense, the heat flow from the material that has a higher temperature. You can use either one of those temperature scale, maybe use Kelvin, maybe use Celsius or Fahrenheit, to a material that has a colder temperature. And so there are some of those collision exchange. When you have those collision with different materials, so there will be those heat exchange or the kinetic energy exchange. Right? And I think what is important in terms of those calculation is these two formulas. You can convert, use the first one, between Fahrenheit and Celsius. You can convert between Celsius and Kelvin, use the second equation. So with both two equations, you can convert between any of that, between any two of that three temperature scales. So heat flow from an object at what to what? To a low temperature. So as I said, if you remember that three thermometers together side by side, and you'll be able to understand what I said here. Even though when you measure the boiling temperature of water, if you use Kelvin, your number reading is 373. If you use Celsius, it's 100. If you use Fahrenheit, it's 212 Fahrenheit. Right? So you have different reading from different thermometers, but you should measure all the same average kinetic energy for the same material at the same temperature. Now what we said here is not the reading you get from measure the temperature of boiling water or freezing water or room temperature water. Not those numbers you get from reading the thermometers. What we say here is each step, right? So each scale in that three thermometers. If I can go back to that slide, I'll tell you what I mean by the step. Okay? You can see here is one line here, okay? And here is another line here, and this is one step. This is one step in Fahrenheit. Right? So then here, from here to here, is one step in Celsius. If you remember what we saw on the other slide, we said 1 Celsius, one step of 1 Celsius degree, 1 Celsius degree is 1.8 times larger than 1 Fahrenheit degree. And probably from this picture, you can see it very easier. Right. So 1 Celsius degree, not the average survey reading. Like today's temperature, today's air temperature in like in this area is about the high temperature today is 76 Fahrenheit, right? But if you see what is today's temperature in Celsius, when you do the conversion, use that formula, right? So I'll put a 76 here, minus 32, then divided by 1.8, and then I will see how many Celsius. Right. So you have 76 minus 32, then divided by 1.8, and the Celsius is 24.4 degrees Celsius. Okay. The reason I do this is I want you to know the difference what are we talking about. So when I said that is one step, each step on the Celsius is larger. But if you measure the temperature of something, like this air temperature in this area, the Fahrenheit is 76. And that number obviously is larger than this 24. Right? I hope you can get that now. Right? So when we see that 1 degree, which means 1 step, and that's the reason when you do these conversions, right? Because so Fahrenheit is a number reading high, and you want to convert it into a number that is reading a little lower but have a larger step, and you need to kind of like simplify and make the number smaller. Think about it that way. Think about if you measure the length. You can measure the length in miles. Or you can measure the length, measure the distance. You measure from here to Wisconsin, right? Madison, Wisconsin. How many miles? You can also measure that in how many feet, and you will get 2 different numbers, right? Maybe from here to Madison, 300 miles. Exactly, about 200 miles. And if you measure in feet, it will be several thousand feet, right? Why is that? Because mile, 1 mile or 1 step is a longer distance. And then 1 mile is compared with our Celsius. And your feet is comparable with the Fahrenheit. So therefore, when you converting from something that you measure with a small step, how many feet, a few thousand feet, and you want to see how many miles your number will be, how many miles that number, how many number of miles that will be a small number. How can you get a small number? You get a small number by subtraction, by divide, and then make the number getting smaller. I mean divide by a number larger than 1. If you divide by some number smaller than 1, then make it bigger. Alright, so that's probably, when I see that, is to help you to memorize the equation. Which means if you sometimes get confused whether you divide by 1.8 or multiply by 1.8, you think about it, it makes sense or not. Right. So then the size of a degree on the Kelvin scale and compare the Kelvin scale with the Celsius, they are the same. Okay. So therefore, the same idea, right? 1 Kelvin is 1.8 times larger than 1 Fahrenheit. Right. So why the Kelvin here and Celsius have the same degree? Again, I put that in the quotation mark. It does not mean the absolutely reading. Just compare step by step. Right? Get that? As I said before, when water boils, if you measure with Kelvin, what is the boiling point of water in Kelvin? 373. What will the boiling point of water boil if you measure with Celsius thermometer? 100. So it's a different number. But what we said here is not to compare those numbers. We compare the step. How many steps or how many degrees of Celsius do you need to go, for example, from freezing of water to boiling of water? 100. How many steps or how many degrees of Celsius do you need to go from water freeze to water boil? What is the Celsius reading at when water freeze? So yeah, so not the reading. We talk about the step, each degree. It's also 100. Because in Celsius, when water boiler in Celsius is at what temperature? 100. What is the temperature when water freezes? Okay. Now, how many degrees between water freeze and water boiler for Celsius? 100. You go from 0 to 100. So therefore, you have 100 degrees of Celsius between water freeze and water boil. That's what we compare. We compare those degrees or the size of a step, like the person working, the person running. Like right now, that guy, or some guy by you, like running like in Beijing, like those 100 meter dash. And he's the champion that the winner can beat because his step is very, very is longer. Never so that's a step, right? Now, what is the step? How many steps you have when you like measure from water freeze to water boil with the Kelvin? Why is 100? It's the same step. You're starting from when water freeze on the Kelvin. What is the temperature when water freeze? 273. So that's your starting point. What is the temperature in Kelvin when water boils? 373. Okay. I will actually go back to that slide with the 3 temperature scales. See here? Water freeze here, 273 in Kelvin. Water boil here, 373 in Kelvin. So therefore, how many Kelvin degrees do you go? 100. Now, how many degrees of Celsius do you go from water freeze to water boil? 100. So therefore, you think about these 2 thermometers or 2 ladders you climb, right? Or 2 stairs. How many stairs do you climb if you want to go from water freeze to water boil on the Kelvin thermometer? 100 stairs. And how many stairs do you climb if you climb on the Celsius thermometers? 100. Now, what we compare in that slide, each degree, which means each step on the stair. Right? Right. So sometimes in the class, in the chemistry class, we like that. Think about not really some numbers, but just think some of those kind of like the relation. Yeah? Those are the relations is compared. You get it. Just sometimes it's right. So one example is if a sick child has a temperature of 40 degrees Celsius, and what is the temperature in Kelvin and Fahrenheit? So then you have 2 equations. Remember that one slide has 2 equations, right? So Kelvin equals Celsius plus what? 27.3, right? And now what about Fahrenheit? Fahrenheit equals 1.8 times Celsius plus 32. Now why I think about that? Again, I don't have really memorized those equations. Just think about that makes sense, right? You know, like for like a certain temperature, for a certain hardness and warmness, if you're reading in Fahrenheit, at today's temperature is 76 Fahrenheit, right? But today's temperature is only 24 degrees Celsius. So you want to convert it from Celsius to Fahrenheit, your number is probably getting bigger. Now how can you make the number getting bigger? You have that 4-hour rating, multiply, divide, subtraction, and addition. Okay? So any important number makes the number getting bigger. You multiply the number by a number that larger than 1, make the number bigger. So now you just remember that 2 numbers. One is 1.8, the other one is 32. Alright, so the first will be 40.00 plus 2073. Very, very easy, right? And what do you get?
313.
313 on 00. This one you have to do some calculations, so therefore you will get 1.8 times 40.00 plus 32. Okay. And you should do the multiply first, right? Then 1.8 times 40 plus 32. I get 104. Okay. Any questions? Okay, now what I write here is a little bit different than what I write on the level notes. Because I here only write 104, but precisely, technically right, you want to get 104.00. So we're going to talk about that in the last few sections of this chapter. Okay? So for right now, you just treating this as just algebra, mathematical equation. Right now you don't have to worry about this. How many zeros, how many digits you take, and how many numbers you write. Alright, let's do a practice. Okay, so this is the first class, and you just getting ready, so you just prepare. So I want to, like say, you have the calculator, right? So you have the level notes print out, and I will not give you the print out for the other chapter, only this chapter. I also like to see if you have those spreadsheet papers. If you don't have the level notes print out, then you will do the practice right away, right? Okay. So you do the practice. What do you do? What ingredient you use? That's the answer. What's the answer? That's okay. Very good. I see like a few quick. Any questions? Yeah, when we do the CRE.
Do you need them today?
No. I just when we finish the chapter, I just yeah.
And what about the quizzes?
The quiz?
Are they going to be online?
The online quiz.
Are we going to print them and hand them to you?
No,
or do them online?
you do online.
Submit them online?
Yeah. You can try like 5 times.
5 times?
5 times, and I will just take the highest score. The CRE is a CRE. No, you just write on the scanner. Yes, just mark on the scanner. Before you mark with the pencil. When we finish the chapter, well, we will use that again. I think we can use like the front side for chapter 1, chapter 3, use our memory. So chapter 5 is 1, 2, 4, 6, 8, 4, 1, 9, 3, 5, 10. Yeah, this is CRE. All those things.
I know, I should have.
You have to learn how to do it. Oh, the 5 times are the same. But each chapter has a different pattern. This 5 times, every time you try, will have the same pattern. No, I don't think so. I think that
Take a look. Ultimately, it's A and C. You said it's really C.
Oh, maybe.
You move the answers around.
Yeah, maybe somehow a sperm or the.
Right. Take a look. And for the midterms, it's a big.
Yeah, two middle terms. Yeah, the first middle term is February 1 to 4.
1 to 4.
Yeah. And then the next will be 5, 6, 7, 8.
What other?
The other three chapters, we start 11 chapters, right? The other three chapters will not have the exam on the, but will be on the final.
They're going to be on the final.
Yeah, I think those are better on the final. On the final, pretty much each chapter has the same amount of questions, but about 7 questions for each
Are we
one.
going to have study guides
For the final?
No, for the 2 tests.
We don't have the study guide for all the exams, but for the 1 and 2, you can use the CRE at the bottom. You can use the negative notes. The first body line, you want to get a kind of a good grade, you just study the CRE questions. If you want to get a very good grade, you study those in the book. There's at the end of each chapter, there's something.